Hi everyone, this is Engineer Melissa and I will be discussing to you the continuation of Chapter 4, the resultants of the force systems. So the first part was already uploaded on my channel, and if I'm not mistaken, it is also discussed during our face-to-face classes for the other section. And then the second part was done through face-to-face classes also, both sections. And for the third part, um, I will be discussing it virtually. Okay, so let's start. The resultant of force systems. So any system of forces, however complex, can be reduced to an equivalent force coupled system at a given point consisting of a force which is equal to the sum of the forces of the system and a coupled vector of moment equal to the moment resultant of the system. This equivalent force coupled system characterizes completely the effect of the given force system on the rigid body. O, diba? Statement pa lang, napaka-complex na. So, let's simplify kung ano yung ibig sabihin ng statement na to. Okay? So, ulitin natin. Any system of forces, however complex, can be reduced to an equivalent force coupled system. So, let's take for an example a beam. Ano? So, we have here a beam that is subjected with different forces. Let's say we have F1, F2, F3, tapos meron pa siyang moment, say M1 and M2. So this is an example of a system of forces. So this system of forces daw can be reduced to an equivalent force coupled system. So anong gagawin natin? So the force, which is equal to the sum of the forces of the system. So magkakaroon ngayon ng summation of the forces and a coupled vector of moment equal to the moment resultant of the system. So this complex or this system of forces can be reduced to a simpler form. So ibig sabihin, we will take the summation of forces along x. Ayan. We will take the summation along the y-axis and we will take the summation of the moment. So the summation of forces now will be the resultants. So here, ito yung maging resultant along x-axis natin and this will be the resultant along y-axis natin. Okay? And of course, this will be our moment resultant. So we can simplify this complex system of forces into a simpler one. So sabihin natin dito, our F1, F2, and F3. Di ba yung F3 natin will have a horizontal forces. Let's say F3x and then this one, we have F3y. So kunin pala lahat natin yung summation of forces along x. So magiging resultant along x na yan. And then kukunin din natin yung summation of forces along y. So yan yung magiging resultant y natin. And of course, the summation of moment. So kung i-drawing natin yan, it will be look like this. So ito na yung ating resultant y. For example, no, meron tong resultant along x-axis, for example lang. So magiging ganyan. And then yung summation of moment. Ayan. So ito na yung equivalent force system or equivalent system ng ating complex system of forces. So this equivalent force coupled system characterizes completely the effect of the given force system on the rigid body. So kung ano yung effect ng ating forces dito, of course, ganun din yung effect dito. So bale, nag-sum up lang tayo ng mga forces to make it simpler. Okay? Kinuha lang natin yung kanilang mga resultant to make it simpler. Okay? So for our coplanar force systems, the resultant of a coplanar force system can be expressed as R, or the Cartesian vector form of our resultant is equal to Rxi plus Ryj, in which yung ating Rx, of course, as we have stated a while ago, it is the summation of forces along x, and then Ry is the summation of forces along y axis. And the magnitude R and the direction theta measured from the x component can be computed respectively from the equations. So it is equal to the square root of Rx squared plus Ry squared, and our theta, or the angle between the x and y axis, will now be equal to this formula, and then the location of the line of action of the resultant with respect to an arbitrary reference point, say O, can be determined by applying the principle of moments. Hence, the summation of the moment at point O is equal to the moment of the resultant at point O. Okay, so let's take an example for us to be able to understand yung concept ng ating force system. Okay, so three forces are applied to a beam as shown. Replace the three forces by an equivalent force couple system at point C. Okay. So we have here a beam that is subjected with three vertical forces. So ang gagawin lang natin dito is to replace the system of force system into an equivalent force couple system at point C. Okay? So our first step here is to determine yung mga resultant of the forces. So unahin natin yung Rx. So makikita natin dito sa forces, all the forces subjected to our beam is vertical. Therefore, walang any involved na forces along X. Therefore, let's say this is now equal to 0. And then for our Ry, the resultant along y-axis is just equal to the summation of forces along y-axis. Therefore, we have here, sign convention natin, all upward is positive. So we have here 80 minus 75 plus 90. So this is equal to 95 pounds. Okay, meron na tayong resultant. Next is the moment. So for our moment, okay, ano bang pinapakuha? The equivalent force couple system at point C. So yung equivalent moment natin will be referred to point C. So the resultant moment will be referred at point C. Therefore, it is equal to the summation of moment at point C. So we have here, unahin natin yung force na to. So we have 80. Again, sign convention, all clockwise will be positive. So we have 80. Moment arm is 16. 75. Okay, subjected sa point C mismo. Therefore, magiging 0 yung moment natin dito. And then for the third force, we have minus 90 multiplied by 10. So minus because it will tend to create a counterclockwise motion. Therefore, this is equal to So this is equal to 380. So what will be the unit? It is equal to 380 pounds dot inches. Okay. So it's time to draw the equivalent force couple system. It will look like this one. Point C natin is nandito sa gitna mismo ng point C. Nakikita natin that the resultant Y natin is positive. Therefore, it will be directed upward. So this will be our Ry, which is equal to 95 pounds. And then our moment is also positive. Therefore, meron tayong clockwise. So the moment is equal to 380 pounds inches. Okay, so this will now be the equivalent force couple system for our problem. Okay, so kung gusto niyo na lagyan pala ng dimension, pwede rin, no? Dimension natin, so we have here 30 inches, and then this one we also have 30 inches. Okay, so this will be now the final answer. Next, couple of magnitude M is equal to 540 millinewton meter, and three forces shown are applied to an angle bracket. Find the resultant of this system of forces and locate the points where the line of action of the resultant intersects the line AB and BC. Pinapakuha dito yung resultant of the system and then yung location niya. So yung location ng ating resultant must intersect line AB, ito yun, and line BC. Okay. Therefore, yung maging sagot dapat natin dito hindi lalagpas sa 120 mm for the location of the resultant, and of course hindi lalagpas dito sa 80 millimeter. Okay? So our first step here is to determine yung mga resultant forces. Unahin natin yung Rx. So Rx is just the summation of forces along x-axis. So we have here, yan. We have here 30 cosine 60 degrees minus 45 Newton. So all right will be positive. Therefore, this is equal to negative 30. This is equal to negative 30 Newton. Next, Ry. So Ry is the summation of forces along y-axis, upward, positive. So we have here negative 10 plus 30 sine 60. Yun lang. So we have negative 10 plus 30 sine 60. So we have 15.98. 15.981 Newton. Okay. So meron na tayong value for the resultant of our Rx and Ry. Next is to identify yung angle between them para makita natin kung paano yung maging direction of our resultant. Okay? So we have here tangent or inverse tangent of Ry all over Rx. Let's say this is our plane. Yung ating Rx is negative 30. So, pag ganito. Tapos, yung Ry natin is pataas. Therefore, yung direction for our resultant will be look like this. Okay? Pataas siya to the left. So, ito yung kunin nating theta ngayon. So, our theta is Ry all over Rx. Ry, 15.981 divided by 30. Therefore, we have 28.04. Our theta is equal to 28.04 degrees. Okay, so itry natin i-locate yung Rx and Ry natin. So, for example, this is our origin, no? Kasi dito yung X, dito yung Y. So, dito yung magiging Rx natin, and then dito yung magiging Ry. So, the resultant will be located somewhere here, no? Ayan yung magiging resultant. But, the problem says, the resultant of this system of forces and locate the points where the line of action of the resultant intersects the line AB and BC. Okay? The line of action of the resultant must intersect the line AB and BC. So, dapat daw yung line of action ng ating resultant is intersecting or will be intersecting AB and BC. Ito yung line AB natin, ito yung line BC natin. Therefore, we can draw a resultant force that is parallel here, no? Basta mag-cross daw siya at line AB and line BC. So, ito na yung ating magiging line of action for our resultant. Yan. So, ito yung pinapahanap ng ating problem. Tupurin natin ito. Ayan. So, bakit natin minove dyan? Kasi sabi nga sa problem, the line of action of the resultant must intersect line AB and line BC. Okay. So, pinapalocate pa yung points kung saan magi-intersect yung ating line of action for the resultant. So, ito na ngayon yung tinatanong sa problem. So, this is, let's say, X, and this will be our Y. Point of intersection ng ating resultant with line AB and line BC. Okay? So, kung ito yung magiging theta natin, ito na ngayon yung equivalent theta naman. If we will reverse the resultant or if we will get the resultant referring to our positive x-axis. Yan. So, theta Of course, ito na rin yung magiging theta natin. Okay? So, our next step here is to apply the moment of the resultant at point B. Magmo-moment tayo dito sa point B. Moment of the resultant point B, okay, which is equal to the summation of moment at point B. Maya na yung x and y. Okay, so yung resultant natin is composed of x and y components, of course. So let's say this is the point of intersection. So ito na yung magiging Rx, and then this will be our Ry. And then same also here, since isang line of action lang sila, isa rin yung magiging value for the resultant, Rx and Ry. Okay, so unahin natin yung Ry by taking the summation of moment at point P. Let's say this is again our x, diba? And then this is our y. Ito yung y from point P to dito. This will be our y. Therefore, we have Ry, moment arm will be x, is equal to the summation of moment at B. So, unahin natin yung nasa gilid. Our moment is equal to 540. So, magiging negative 540 millinewton meter. Or, this is also equivalent to 540 newton dot millimeter. Okay? So, 540. Minus 10, moment arm is 120. Tapos, yung force natin dito, so we have plus 45 multiplied by 80. Okay? So, meron tayong value ng Ry kanina. Our Ry is equal to 15.981 Newton. Therefore, we can easily solve for the value of x. Therefore, x is now equal to it is equal to 116.4. 116.4 millimeter. Okay? Next, mag-summation of moment ulit tayo at point B kasi kanina Ry lang yung nagamit natin. Kasi same line of action for our Rx and then yung ating point B. Therefore, we can utilize this point para magamit naman natin yung Rx in determining the value of y. Ngayon, yung Ry naman yung maneneglect because same line of action with our point B. Okay? So, moment of the resultant at point B is equal to summation of moment at point B. So, we have here Rx multiplied by y is equal to negative 540 minus 10 multiplied by 120 plus 45 multiplied by 80. We also have a value of Rx kanina na solve na natin which is equal to 30. Okay. So 30 na lang kasi we already followed the direction 30, this one 30 Newton papuntang left. Directed to the left na siya. Therefore, hindi na natin kailangang isulat pa yung negative dito kasi magiging redundant na. Okay? So, 30 na yung gagamitin natin yan. So, pag ginamit naman natin yung negative 30, dapat yung direction for our Rx will be ganun, to the right para magamit natin yung negative 30. Okay? But anyway, since pinalo na natin yung direction, yung proper direction, no need na ilagay yung negative. Okay? So, we have 30. Y is equal to negative 540 minus 10, 120. Diretso ko na sa calculator. Plus 45, 80. Diba, naglolo ko na yung aking tab. Okay. So, it's just this one, 30 multiplied by y tapos to. Naglolo ko yung aking tab. Therefore, y now is equal to 62 millimeter. Is equal to 62 millimeter. Okay. So, upon looking at the illustration, yung ating x is equal to 116.4. So, hindi siya lumagpas sa 120 millimeters natin. Therefore, we can assume na, somehow tama yung sagot natin because hindi niya nilagpasan yung 120 millimeter. And also for our y, makikita natin it is just 62 millimeter and it is lesser than 80. Therefore, yung line of action for our resultant is actually crossing line AB and line BC. So this will now be the final answer. Next, determine the magnitude of F1 and F2 and the direction of F1 so that the loading creates a zero resultant force and a couple on the wheel. Pinapa-determine dito yung magnitudes of our F1 and F2 and also the direction of our F1. Okay. So the loading creates a zero resultant force and a couple on the wheel. Okay, so this is the wheel and it is subjected with four forces, F1, F2. Let's say this is F3 and this is F4. Pinapakuha yung value ng F1 and also the direction of F1 and yung magnitude ng ating F2. Okay? So, ganun pa rin. We will take the resultant of X, the resultant along Y-axis. By looking at the illustration, makukuha na natin dito agad yung value ng F2. If we will take the summation at 0.8. Diba? Yan. Sabi natin nung nakaraan, pag nag-moment tayo sa isang point kung saan may nag-act na force, that force will now automatically be cancelled. Therefore, kung nag-moment tayo dito sa point A, makakancel na yung F1 natin. Therefore, ang missing na lang will be F2. Okay? So, makakasolve na tayo agad ng isang force, which is now the F2. Okay. Taking the summation of moment at point A. Sabi sa problem natin na the loading creates a zero resultant force and a couple on the wheel. Therefore, the summation of moment at A is basically equal to 0. Have F2 moment arm. Dito tayo nagmo-moment. So, hanapin natin yung perpendicular distance. So, ito ngayon yan. Diba? Itong distance na ngayon yan. So, hinahanap natin yung distance na to. So, we know that this is the radius. So, this is 0.75. Next, ito naman yung kukunin natin. So, alam natin that this is also a radius. So, this is 0.75. Okay. So, kung 30 yan, this is 60. Therefore, this one is 0.75 cosine 60. So, this is 0.75 cosine of 60, this distance. So, we have 0.75 cosine 60 is 0.375. So, this is 0.375. Okay? So, mamaya, magagamit siguro natin to. So, kukunin na rin natin. So, this distance is 0.75 sine 60. Kunin na lang natin for future use. 0.6495. Or let's say 0.65. This is 0.65. Okay. Therefore, yung magiging moment arm for our F2 is 0.75 plus this distance 0.375. Next, this force. So we have here plus 60. The moment arm is this one, diba? Ito yung magiging moment arm. the distance perpendicular to our point. So it is 0.375. Next one, this force. So we have here force B, 30 pounds, 90. Okay. So let's say, ito yung ating B, Y. Ito naman yung ating B, X. Ano? Okay. So yung BY natin and BX, we need to determine kung ano yung values nila. Okay. So our BX is equal to, so maghahanap ngayon tayo ng angle. Okay. So this one is 45. Ito, 45. Therefore, if we extend this one, extend natin yan, tapos kunin natin dito, kakaroon tayo ng 90 degrees. Kung 45 yan, this is also what? 45 degrees. And 45 degrees rin yan. Therefore, yung ating BX, sabi niya dito, 90 degrees yan. So, kung 45 yan, this is also 45 degrees. Therefore, our BX is P cosine of 45 degrees or 30 cosine of 45. So, we have 21.21. We have 21.21. And then, our BY, since 45 degrees yan, that is equal. Okay? BX is equal to B1. Okay. Ang next nating gagawin is to determine kung ano yung moment arm. So, for our BX, ito yung ating BX. So, pag nag-moment tayo sa A, ano yung distance? Diba ito yan? Ito yung distance na to. This will be the perpendicular distance. Diba? So, we have here, kunin natin to. Let's say, meron na pala tayo dito. This is 0.375. Kunin na lang natin to. Okay. So, by referring to this triangle, itong triangle na to. So, sabi niya, we have here 45 degrees. Kasi 45 yan. Of course, 45 na rin to. So, 45 degrees. Tapos, this is 0.75 radius ito. Ayan. Okay. Therefore, this one is 0.75 cosine of 45. Cosine of 45. So, this is 0.53. And then this one, 0.75 sine 45 is 0.53 also. Okay, so 0.53, 0.53. Now, sige, sulat muna natin dito. For BX, dito tayo mag-moment at point A. Ito yung ating BX. Therefore, magkakaroon ng clockwise moment. So, plus BX, the moment arm will be 0.53 minus this one, 0.375. Okay? And then, yung ating BY, ito yung BY natin. Plus BY, the moment arm will be, ano to? So, we have here, 0.53. Tapos, we will determine the distance dito. You know, 0.65. So, we have 0.53 plus 0.60. Okay. Ano pa? Tapos yung moment natin to. Ito yung nakalimutan nating ilagay nung nakaraan. Yung moment natin dito. So we have here minus 80 pound-feet is equal to 0. So BX is 21.21. BY is also 21.21. So, the missing now is the value of F2. Okay, so by computing the value of F2 by using your calculator, that is now equal to for our F2 is equal to 25.94. 25.94 pounds. Okay. So F2 is 25.94. Next, we will determine the value of F1. Okay. So let's take the summation of meron na tayong value ng F2. So we can take the summation of forces along x-axis. So yan na yung magiging resultant at x-axis natin. And then sabi dito, the resultant force is equal to 0. Therefore, it is equal to 0. Okay? So we have here F2. Lahat ng forces along x, F2 plus 60 minus bx natin is 21.21. 21.21. Tapos yung F1 natin, let's just take it as F1x, no? F1x minus F1x. Yeah. F1x. Kaya na minus F1x is equal to 0. So, meron tayong value kanina ng F2, which is 25.94. Lolo ko ng aking tablet. Therefore, F1x is now equal to so it is equal to 64.73. 64. It is equal to 64.73 pounds. Okay? Meron tayong value ng F1x. Now, for our Ry, taking the summation of forces along y-axis. So, yan na yung resultant y natin. It is also equal to 0. So, we have here, okay, F2 wala, dito wala, dito. So, we have negative by. So, negative 21.21. Bakit ganun? Negative 21.21 plus F1y. Ito yung F1y natin. Yan. F1y. And it is equal to 0. Therefore, F1y is also equal to F1y is also equal to 21.21 pounds. Therefore, F1 is just Therefore, F1 is just equal to the square root of the x component and then the y component. So we have here F1 is equal to square root of F1x squared plus F1y squared. So that is equal to 64.73 squared. Is equal to 68.11. 68.113 pounds. Okay. And then yung theta, of course, is equal to inverse tangent of F1y all over F1x. So it is equal to 18.15 degrees. So the theta is equal to 18.15 degrees. Okay? So this will now be the final answers. Okay, next. Determine the magnitude and direction theta of force F and the couple moment M such that the loading system is equivalent to a resultant force of 600 Newton acting vertically downward at O and a clockwise couple moment of 4,000 Newton meter. So, pinapahanap dito yung value ng ating force F. Okay. By the way, dito pala is Tama. Determine the magnitude and direction theta of force F. So this one, force F. And then yung couple moment, F tsaka M. Such that the resultant force is acting at point O. So meron daw tayong resultant dito. So the summation of the forces here is equal to 600 Newton acting downward at point O. Kaya yan. And then meron tayong clockwise couple moment of 4,000 Newton meter. So nandito daw yung moment natin, which is equivalent to 4,000 Newton meter. Okay? Just like before, we will take the summation of forces along X. So that will now be the what? The resultant of forces along X axis. Okay? So for this force, we have here, this is 800 cosine 60. 800 cosine 60. So this is now 400, no? This is the X component. And then for this one, 800 sine of 60. So we have here 692.82. 692.82. So these are now the equivalent components of this 800 Newton. And then of course, let's say this is Fy and then our Fx. Okay? So for the summation of forces along x-axis, so we have negative 400. Ayan, directed siya sa left. So kaya negative 400 plus Fx is equal to 0. Therefore, Fx, sorry. Tama. Fx is equal now to 400 Newton. Okay. So, bakit ko siya in-equate ng 0 dito? Because, sabi dito sa problem, yung resultant force daw is only 600 Newton that is acting vertically downward. Acting vertically downward. Wala siyang sinabing resultant force that is acting horizontally. Okay? Kaya in-equate ko siya into 0. The resultant force along x is equal to 0. Therefore, Fx is equal to 400 Newton. And then for our y-axis, so we have summation of forces along y. Yan na yung magiging resultant y natin. So we have here 692, negative 692.82. All forces upward is our positive. Tapos meron tayo dito sa baba, plus 300 minus Fy. Okay. The resultant is equal to 600 Newton. Directed downward, kaya negative. Okay? Therefore, Fy is equal to that is equal to 207.80. 207.80 Newton. Okay? So our theta now is equal to the inverse tangent of Fy 207.18 divided by Fx. So that is equal to 27.38 degrees. 27.38 degrees. Okay. And then, force F pala yung hinahanap. Therefore, our force F is just equal to the Fx squared plus Fy squared. So that is equal to 400 squared plus 207.18 squared. 450.47. Yung theta is 27.38. Okay, so na-compute na natin yung pinapahanap ng dalawa, which is the force and then the theta. What is left now is the moment. Okay, so ganun din. Taking the summation of moment at point C is equal to the resultant moment at point C. Okay. So mag-moment tayo lahat dito sa, point O pala, hindi C, point O. Summation of moment at point O is equal to the moment of the resultant at point O. Moment tayo lahat sa point O. So, unahin natin yung Fy. So, we have here positive Fy. So, we have 207.18. Moment arm is 2 meters. Okay? Next, yung 300 minus 300. 300. The moment arm is 3 meters. And then this one. We have plus 692.82. Moment arm is 2, 3, 4. 4 meters. And then, this one. Yung moment na to. So, in-assume dito na it has a clockwise. So, lagyan na rin natin ng clockwise. So, positive M. Since ganyan yung nasa drawing. Plus M. Is equal to, ano daw yung resultant ng moment natin? 400 or 4,000 Newton meter. So, this is equal to 4,000 Newton meter. Therefore, the value of M here is now equal to So it is equal to 1714.36. 1714.36 Newton dot meter. Okay? So yan na ngayon yung isang pinapahanap sa problem. So this will be now the final answer. Okay? This is for the force and this is for the moment. Okay. So, proceed na tayo sa next topic, which is the non-coplanar force system. So, pag sinabi nating non-coplanar force system, they are not just lying onto a single plane. Hindi na lang X and Y yung involved dito, but we will be dealing with X, Y, and Z plane. Okay. Or, in short, 3-dimensional. Okay. So, here, the resultant or the Cartesian vector form of the resultant is equal to Rxi plus Ryj plus Rzk, in which yung Rx natin, just like before, is the summation of forces along X, Ry, summation of forces along Y, and then Rz is the summation of forces along Z. And this is now the cosine angles, no? Or the angles between the axis and the resultants. Okay? And then the value of the resultant is the square root of the squares of the components. Ayan, alam naman na natin to. And then for the moment, the Cartesian vector form for our moment is equal to mxi plus myj plus mzk, on which yung mx is just equal to the summation of moment along x-axis, my is the summation of moment along y-axis, and mz is equal to the summation of moment along z. And then the magnitude moment is the square root of the squares of the components. Okay. So the first equation states that the resultant force of the system is equivalent to the sum of all the forces. And the second equation states that the resultant couple moment of the system is equivalent to the sum of all the couple moments plus the moment of all the forces about a reference point. So, same concept lang sila nung natapos nating discussion, yung katatapos lang nating discussion. Ang difference lang dito is nagkakaroon na ngayon tayo ng z-axis. Okay, so i-apply pa rin natin kung ano yung alam natin dun sa coplanar force system. So, let's start with our first example here. Number 1, the resultant of the parallel force system shown in the figure is a couple that can be expressed in Cartesian vector form as C is equal to 1160J minus 2250K inches pounds or pounds inches. Determine the magnitudes of forces F1, F2, and F3. Okay. So makikita natin dito sa figure that all the forces is acting on the X direction. So we have here 6 forces, and all of these 6 forces are acting on the X direction. Okay. Meron tayo kanina that the Rx is equal to the summation of forces along X. The resultant Y is equal to the summation of forces along Y. Rz is equal to the summation of forces along Z axis. And the resultant moment is equal to the summation of moment at a certain point. Okay. Dito, sa ating illustration, makikita natin na all directions are directed on the x directions or all the forces are in direction of x directions. Kaya pwede na nating i-neglect yung ating y tsaka yung ating z. Okay, so we are left with the resultant x and then the summation of moment. Okay, let's read again the problem. The resultant of the parallel force system shown in the figure is a couple. Okay, couple lang daw yung resultant ng ating parallel force system. Therefore, the resultant is equal to 0. Okay? Kasi sabi niya dito, the resultant of the parallel force system is a couple. So, moment lang yung resultant ng ating forces. So, the resultant of forces or the resultant of x, y, and z is now equal to 0. Okay? So, since yung ating ry tsaka rz naman is equal to 0, diba ito yung equation natin for the resultant kanina. 0 naman to. Therefore, the resultant is equal to Rx is equal to the summation of forces along x and they are equal to 0. Okay, so let's begin. Unahin natin itong first force here. Therefore, sabi natin kanina, the resultant is equal to 0. Therefore, 0 is equal to, and then summation of forces along x. So we have F1 plus F2 plus 75. Tapos ito, minus 125 minus F3 minus 90. Okay? So we have F1 plus F2 minus F3 is equal to okay. So it is equal to 140. Okay? So this is now our equation number 1. Next, gamitin na natin yung summation of moment. Okay? So we have the resultant of moment at y-axis. Okay? So gamitin natin yung y-axis. So bakit yung y-axis yung gagamitin natin dito? Bakit hindi tayo magsisimula sa x-axis? Okay. Hindi tayo magsisimula sa x-axis kasi ang makikita natin dito sa couple na given or yung ating resultant of the parallel force system, nagsimula sa J tsaka K. Wala yung I. Ibig sabihin, the summation of moment on the x-axis is 0, diba? J tsaka K lang to. Therefore, ang involved lang dito is Y tsaka Z axis. Okay? So, let's take the resultant moment on the y-axis is equal to the summation of moment along y-axis. Okay, so this is 160 and it is equal to, okay, anahin natin dito. So magmo-moment daw tayo dito sa y-axis. Therefore, we have F1. The moment arm is 8 times 3. 888. So we have 24. Okay, clockwise siya because if you will see dito sa y-axis, it will create a counterclockwise. Sorry, negative counterclockwise. Okay. Next, dito F2 minus F2 multiplied by 16. Okay, and then yung 75 natin, there is no any distance perpendicular to our y-axis. Therefore, it is 0. Okay, so ilagay na natin plus 0. Tapos dito sa ika-4, so we have plus 125. Moment arm is also 24. Tapos, plus F3, moment arm is 24. Tapos yung last, plus 90, moment arm of 8. Okay, so simplify natin. So, lahat ng F1, F2, and F3, lagay natin dito sa left side. So, we have here 24 F1 plus 16 F2 minus 24 F3 is equal to it is equal to 2560. So we have 2560. So this is now our equation number 2. And then let's take the summation of, or let's take the moment, resultant moment at the z-axis. It is equal to summation of moment at the z. So we have here negative 250, 2 to 50. So negative 2 to 50 is equal to, so dito naman tayo magsa-summation of moment ngayon at the z-axis. Yan. So F1 will be equal to 0, no? 0. Tapos F2 plus F2 multiplied by 20 plus 75 multiplied by 20 minus 125 of 10, okay? Minus F3 of 30 minus 90 of 30. Okay, so simplify ulit natin. So we have 20 F2 or negative 20. Sige. Okay lang. So negative 20 F2 plus 30 F3 equal to negative 200. Okay? Or 20 F2 minus 30 F3 is equal to 200. Okay, so this is now our equation number 3. So we have 3 unknowns, 3 equations. Therefore, we can solve F1, F2, and F3 simultaneously. Okay? So we have 1, negative 1, tapos 140. Next, we have 24, 16, negative 24, and then 25, 60. Next, we have 20, negative 30. Sorry, F1 is 0. F1 is 0. So this is 20. And then negative 30. Tapos 200. Zero yung ating F1. Okay. Okay. Zero yung ating F1 yan. Zero yan. Okay, so our F1 now is equal to 100. F1 is 100. Tapos F2 is 100. And F3 is 60. Okay. So ang sagot natin, F1 is equal to 100 pounds. F2 is equal to 100 pounds. And F3 is equal to 60 pounds. Okay? So that is by using your calculator. So kung walang ganyan yung function yung calculator, you may do it manually. Okay, so that will be the final answer. Okay, for the next problem, find the x and y coordinate of the point where the resultant of the 3 forces crosses the plate. Okay? So yung plate natin, it is subjected by 3 forces, 25, 35, and 40 kilonewton. And kung mapapansin nyo, these 3 forces is acting on the z direction. Okay, so z direction. So pinapahanap sa problem yung result or yung position ng ating resultant force. Okay? So pinapahanap yung coordinates. So let's start. Pagaya ng ating previous example, no? Our forces is acting only on the z direction. Therefore, the resultant along x and the resultant along y axis is equal to 0. Kasi wala tayong nakikitang forces that is acting in direction of these both axis, the x and y. Therefore, we are left with rz. Therefore, The resultant is equal to Rz, and it is equal to the summation of forces along z direction. Okay, so let's start. So we have R is equal to the summation of forces along z direction. So we have negative 25 minus 35 minus 40. Therefore, the resultant is equal to negative 100 kilonewton. Okay, next. So meron tayong resultant. So the resultant is acting downward, no? Kasi negative to. Acting downward. Therefore, hindi natin alam yung exact position. Pwede siya dito, nandito yung R. Pwede rin siya dito, okay? Or dito, hindi natin alam. So, pwede tayong mag-assume ng isang position of our resultant, no? Assume lang naman. Para ma-imagine natin how will it rotate. Okay. So, unahin natin yung resultant moment on the y-axis. Or, sige, x-axis is equal to the summation of moment along x direction. Ibig sabihin, kukunin natin yung moment on the x-axis dito. Ayan. So, kung ito yung assume natin, this is our y. Okay, yan yung y distance na hinahanap natin. So, we have here negative r. Okay, negative r. Tapos, y. It is equal to summation of moment. Tapos, sa x direction. So, we have here 400 multiplied by, so ilan to? Okay. Ito yung ating, 40 pala yun. 40 kilonewton. 40 kilonewton. So, ito yung kanyang distance. Perpendicular distance. Kung ito ay, kung ang radius niya ay 4 meters, this is also 4 meters. Therefore, this distance is equal to 4. This is 4 sine of 30 degrees. Okay. So, we have 4 sine of 30 degrees. So, clockwise siya. Next, dito sa force na to, sa force B. So, we have here minus 25. So, ano yung distance? Ito yung distance na to. Ayan. So, this is also 4 meters. Therefore, this is 4 sine of 40. No? So, we have 4 sine of 40. And then, the next one, ito. So, we have 35 minus 35. The moment arm is simply the radius. So, we have here 4. Okay. So, yung ating R kanina is equal to negative 100 kilonewton. But take note that this is 100 kilonewton downward. Dito, ginamit natin yung direction niya na mismong downward. Therefore, it is safe na maglagay tayo dito ng negative. Because it is pertaining na it will create a counterclockwise direction. Okay, so we have here negative 100. So, we are left with y. Therefore, y is equal to 40%. Therefore, y is equal to negative 1 point, or sorry, positive. So, we are we have 1.24 or 1.243 meters. Okay, so nakuha natin is positive y, positive y. Therefore, yung assumptions natin na that the location of our R is on the left side. Okay? Ng ditong part na to kasi positive yung nakuha natin. Meaning, tama yung assumptions natin. Again, positive kaya tama yung assumptions natin. Kung nakuha natin dito is exactly negative, kung negative yung nakuha natin dito, meaning mali yung assumptions natin na nandito yung ating resultant. So, for this case, positive siya. So, tama yung location na nasa left side siya ng x-axis na or nanditong area na to yung ating resultant. Okay? Next, Let's take the resultant of the moment on the y-axis is equal to the summation of moment on the y direction. Okay. So, assume ulit natin na ito yung ating resultant. So, we will take the summation of moment on the y-axis. Dito tayo magbo-moment. Therefore, we have r. Tapos, ano yung magiging distance? Ito na yung magiging distance. This is x. Okay. So, r multiplied by x is equal to the summation of moment on the x-axis. So, unahin natin to. So, we have here 40. So, the distance is what? Ito yung magiging distance. Ayan. So, that is equal to 4 cosine of 30. So, positive kasi clockwise direction. Next, dito na. So, we have minus 25 multiplied by, so, moment tayo sa y-axis. So, dito. So, ito yung distance na to. So, this is equal to 4 cosine of 40. So, 4 cosine of 40. Next, for the 35. Okay, so nag-moment tayo sa y and it is along the y-axis. Therefore, it is equal to 0. Therefore, r, meron na pala yung value ng r. R is equal to 100 kilonewton. Therefore, x is equal to 4 cosine r cosine 40. Therefore, it is equal to 0.619. 0.619 meters. Okay. So, again, positive ulit yung nakuha natin for the value of x-axis. Therefore, tama yung assumptions natin na nandito nga yung ating resultant. Okay? Nakachamba tayo na nandito yung location ng ating resultant. So, kung in-assume nyo na nandito yung value ng ating resultant, nandito yung location ng ating resultant, I should say, okay lang din, kasi ang magdi-dictate niyan will be the sign conventions kung ano man yung magiging sagot niya. So, for this one, we have, so kung ilalagay na natin yung coordinates kasi x and y coordinates yung hinahanap, therefore, we have, so nandito yung x, ayan, dito sa bandang likod, therefore, we have negative 0.619, and then yung y coordinate niya is negative 1.243. So, ito na yung magiging x and y coordinates. Okay? So, that will be the final answer.